Hello, we're going to start looking at the other part of a coordination complex that can impact the size of the delta. This is the ligand, and there are three types of ligands that we will see. The first one is sigma donors, and so this is an example of a sigma donor. A sigma donor has one pair of electrons that can donate to the metal in a sigma bond. A pi donor, the second type, and I've given an example here, the hydroxide, this molecule has three lone pairs. So if one donates towards the metal in a sigma bond, a second one can donate towards the metal in a pi bond. And so this is a pi donor. The third type of ligand is a pi acceptor. This complex has a lone pair that can donate towards the metal in a sigma bond, but it also has pi bond and pi star. And if you have a pi star lined up next to the metal, and remember the pi star's out of phase, the metal can donate electrons back to the empty pi star pi star bonds. We have a sigma donating toward the metal donating back to the pi star. When we look at this, we're looking at how do they impact that delta. And it turns out that strong field ligands are pi acceptors. They make them delta large and low spin for the overall complex if we have a choice. Well, electrons are more likely to pair up than to go into the higher anti-bonding orbitals. The sigma-only donors are strong, but not as strong as a pi acceptor. Pi donors are weak field ligands. They accept the electrons back, they weaken the distance, and give us a small delta, leading to a high spin complex. In a later video, you will look at the MO diagrams and look at why the pi acceptors and the pi donors impact the field this way.